I know this is going to look like a boring movies or video, so I'll make it really short. I discovered how to get LT-Spice to create over Unity in a very extreme manner, and it involved keeping. First of all, I was using a Bewley archetype um, form of a circuit, in which it's composed of a ring of capacitors, 4 of them, in a square ring surrounded by two inductors that are opposite each other on the outside of the ring, and then I threw in some other things to get it to oscillate, some extra inductors. And then you can add other things like batteries to charge or whatever, but that's if you can get it to regulate with the help of switching and timers, which I managed to do in Paul Falstad, or my version of Paul Falstad Simulator, which the circuit can be found at is.gd/. Can a dead battery charge itself? But the copy I have made on my website, that's a mirror of the posting that I put on Quora, can be found at is.gd/ self-charging. And that has all the links in it. But one thing I like to point out, and I might as well state it now, is that how I got LT-Spice to do it was I made all of the capacitors in the circuit, they had negative series resistance of 100 milliohms, negative 100 milliohms in all of the capacitors, and they were small. And I kept the values of the caps and coils small. So the caps were 10 picofarads, and the coils, well, they were not all small. The transformer coils were, I think they were 100 millihenries. Yeah, 100, I think so. Yeah. While the oscillating coils, the air core coils, were inductors off to the side, the pair of them were 1 Henry each. Or were they? You know, I don't think so. No, they were the same size, 100. No, not a milli. No, they were. Oh shoot, I don't remember what they were. I think they were 100 nanohenries. That's right. All of the 4 coils were 100 nanohenries. I had to keep them very small. And the wire gauge used to wind them was 15 Og, which is kind of heavy-duty wire, you know. Lacking resistance, but pretty troublesome wire to wrap a coil with. At least it's not a big coil, or not too many turns of windings. So that was some of the problems I had. Then I could make the voltage source powering this thing 1e to the negative 18 volts. I can't remember what the term is for that, but it's pretty small voltage. And I think I had a snap switch that turned it on just for like 10, I don't know, picoseconds or nanoseconds, I forget which it was, just once in the beginning of the simulation, and then the whole thing just escalated. Its funny thing was it drew in more power, but never more than something like microvolts or comparable amount of amperage from the source. But the voltage and the amperage building up in the circuit were huge. The voltage, I can't remember what it was. I think they were on the order of, I don't know, teraamps, megavolts or more, in 45 picoseconds. So it just kept escalating. It just kept going up and up and up, because I wasn't regulating it with the timers to break the ring. See, the ring of capacitors surrounded by a pair of inductors on opposite sides of each other outside the ring, it's an uncanny archetype in which it just wants to mushroom into a huge amount of energy. It's unbelievable. So you have to break the ring periodically or frequently actually, to break the ring is to have the ring intermittent in existence, so as to allow the dissipation of the energy that is quickly mushroomed, so that a semi-steady state can be maintained, although it's a little tenuous because there's no such thing as steady when dealing with electrical reactants. It's either blowing up in your face or shrinking down to nothing. So you use switching to both create a temporary surge to feed the thing, but also to break the thing periodically so that it doesn't surge too quickly, and then you can time the rate at which it keeps breaking and what's the duty cycle and whatnot, so that you kind of balance dissipation with growth, and then you alternate between growing too fast versus growing too slow. So it's like flying, you fly too much to the left and then you correct, and then you fly too much to the right and then you correct the other way, and you weave back and forth. Hopefully not, you don't give yourself whiplash, but so what I discovered was that if I put negative 100 milliohms of series resistance in the 10 picofarad capacitors, I also then had to put positive series resistance and negative parallel resistance in all the coils. And the value I use for both is the same absolute value, equal to the resistance of the coil based on its inductance, assuming inductance is the cause for its length. How many turns and how long does the wire end up becoming, and then the gauge combined with the length of the wire will give the resistance of the wire. So I use that value for the positive value for series resistance, and then the negative value for the parallel resistance. See, I didn't know series versus parallel were two types of resistances. For coils, for capacitors, there's only one kind, series resistance, so that's negative. And by doing this and keeping, everything else, the parameters small, the inductance and capacitance parameters small enough, then the thing just takes off, and it produces so much energy from 1e to the negative 18 volts, a single instant in a microsecond of time, or actually a few picoseconds or something. It just mushrooms, and it wants to do nothing more but keep mushrooming. So the reason why I thought about it this way, I was trying to solve a problem. LT-Spice was not giving me the results I am accustomed to in my version of having modified Paul Falstad's simulator. I thought I modified his simulator correctly, and now I have to admit I am wrong. I thought I was putting in series resistance in all the caps and coils, making it more realistic, and lo and behold, it made a lot of my circuits not work anymore to produce over unity, but a lot of them got better. And a lot of new circuits that wouldn't work otherwise, such as Bewley's archetype, all of a sudden came to life. And now that I assumed there was series resistance in all the caps and coils, but I was wrong. I didn't put series resistance in. What I did was, and I always considered this weird, but what I figured out today was that the code, the Java software code in Paul Falstad's simulator, what he does for coils, and for capacitors actually, for both, he took electrical reactance formula and he embedded in there, and the point is, you feed the circuit voltage, but it spits out current, right? You have this flow of current going from one component to the next. Well, what determines that flow? Electrical reactance. Wouldn't you know it? Current comes out of electrical reactance. And in the universe, all it is voltages. And so current is an artificiality. It's a fabrication resulting from electrical reactance. Isn't that amazing? It's uncanny. I always wondered, how come those formulas, they're exactly electrical reactance formulas. And what he does is he uses them to create a current source. And then the current source defines the output of current from that component as it interacts with all the other components, changing their voltages because of the transfer of voltage via current. And so then the component gets a little more voltage or a little less, and then he uses electrical reactance to figure out how current moves around in the circuit. It's uncanny. So all I was doing was enhancing it so that it wasn't right anymore. And so, yeah, it's okay, but that's not the way it works. Because I thought I was putting in resistance. Just because I called it resistance doesn't make it so. What I was doing was see, the electrical reactance formula, they're based on either capacitance or inductance, depending on which formula you're using, times frequency times 2 pi. And the output is either capacitive reactance or inductive reactance, which becomes capacitance or inductance for the next iteration. Because over time, what the formula does is it feeds itself, causing reactance to either expand or contract. And we're just dealing with potential energy here, namely frequency. We're not dealing with anything else. So we can do this with potential energy. We can modify its size, or its amplitude, I should say, because all we're doing is modifying frequency. We're not playing with energy per se, kinetic energy, which is what conservation of energy pertains to. Nobody tells you this. Oh, energy in has to equal energy out. Well, yeah, because kinetic energy is tied to matter. And so, yeah, matter looks pretty stable, yeah, because that's kinetic energy. But frequency is not kinetic energy. It's not tied to matter, and it's free to do as it pleases. And yet frequency does impact kinetic energy. Potential energy does impact kinetic energy. So in an indirect manner, we sidestep conservation of energy. It's so simple. Anyway, so what I was doing was I was adding in a factor to multiply against the frequency, or the capacitance or inductance, call it what you will, 2 pi being constant. So I was adding in a factor, and for capacitors, it was always 10 milliohms, because I assumed the figure for ceramic capacitors. And for inductors, it was based on the wire size and the inductance of the coil. And it turns out to be very close to the inductance value, slightly less. So for a 1 Henry coil, it turns out to be 0.988888, and the eighths go off to infinity. So it's a fraction of repeating eighths, repeating decimals. And that turned out to be the formula that I was using based on, studying wire charts and whatnot and inductance calculators. I came to that conclusion, so I had a certain factor I would use to multiply against to create that result. The factor was smaller than that, but the end result was, once you figure in the 2 pi and all, it ends up being that figure. So divide 0.9888 by 2 pi, and I think you'll get the response. It's something, I don't know, I can't remember what it was, 0.325 or something. Any case, so that's all I was doing. I was enhancing the current coming out of the caps and coils. So yeah, it's not exactly series resistance. I thought it was. But having figured that out, I thought, shit, now I got this Bewley archetype that only works in my realistic simulator due to what I thought was series resistance added into it. And now it's proven to be a false god that I've been worshiping all this time. Yet it works, so I got to make it work now in LT Spice. But LT Spice, let's see, what options do I have when I put in the values for the components? Well, I have all these exotic stuff I've never used before, and I still don't understand all of them. But so I think I'll mess around and see what happens, and that's what happened. The Edison approach, when you're a dummy, that's all you can do. Fumble and bumble and stumble along. So I'd try different things, and this is what I came up with. So I've written it all out onto the LT Spice software. So the image for that, the screenshot for that is is.gd/Bewley archetype LT Spice. and that's the image. While the software code, the ASC file, the Apple Samuel Charlie file extension for LTSpice, that's is.gd/self-charging. No, self-charging is the, no, I didn't make one for the ASC file. No, self-charging, that's for the text file that is a copy of what I posted on Quora in answer to the question, can a dead battery charge itself? And of course, I always try to be a little bit coy about teasing or baiting people to see if they'll bite my hook, and then I can reel them in. With a seemingly innocent question made by an ignoramus, and anybody who doesn't know me yet will go for the bait because it's designed to hook you and reel you in, and so it's like, everybody's saying, oh, no, you should, well, maybe if you rub the battery on your coat, or let it sit there for a while, because the plates are not fully, and they're all valid answers from their point of view, because they didn't know what I was setting them. It's a setup. I was setting them up with that question. In reality, the question is, can you create a humongous, any amount of free energy you want to, so to speak, per unit time? That's the limitation, per a specific unit of time. Can you create any X amount of energy you determine you want to create in a specific time frame from almost nothing? Almost nothing. Almost. This is significant because it's not nothing. It's almost nothing. You may not be able to measure it. It's so teensy-weensy. But I didn't want to say that, right? Because then, they'll blow me off, right? Everybody will blow me off. So I said, can a battery charge itself? A dead battery. Can a dead battery charge itself? And, of course, assuming it's not damaged. If it's still in working order, it just doesn't have any juice to it. Can it charge itself? And, of course, the guy who set up the Ritali website, RITALIE.com, yeah, he does it. He uses high voltage, low current to charge a battery, and then he discharges that battery to charge another battery with high voltage, low current, and the end result is he comes out ahead. The batteries, as he alternates back and forth which one is charging the other, actually they build up in time. They build up their overall charge in both of them. And so I thought, well, that's uncanny, but can you get it to do it at the same time? And say, yeah, of course. It's called electrical reactance. And, of course, John Bedini had the same approach. Ritali basically took the same approach that John Bedini took. You swap the batteries. But I thought, hell, why swap them? Just do it now all at once. And so the Paul Falstad version at is.gd/Bewley archetype, that screenshot shows that from 1 femtovolt of charge on both of those dead batteries, they can charge up the circuit to, I think it was 70, or was it 45 volts? Somewhere in the vicinity, in the ballpark of 50 to 100 volts in 9 minutes. And then once you've got it there, surged to that level of intensity, then you can swap out your switching, with the use of switches, swap out your various timers, your clock timers that are regulating how often and how long a duty cycle are the switches open or closed, so that you can have a semblance of maintenance and organization and consistency to maintaining the energy level that you've now surged to charge the batteries with that level of energy. And then you adjust. Then I noticed you have to have a resistor nearby that's very low, like 1.5. It can't be 1. I've realized it can't be 1 ohm. It has to be slightly more. So usually I use 1.5 ohms, and then you use that for surging. And then when you get to your level, your target, Then you adjust the resistor to adjust your balance of volts to amps so that your battery gets the correct ratio delivered to itself when it's charging. And of course, you also have to pay attention to what the net result is being. What is the voltage level? It has to be something like 25% more than the voltage level of the battery. Is that right? 25? I can't remember the figure. You know, it depends on the batteries and the situation, but nickel metal hydride is the best battery to use because it's the most likely to revive. It was literally invented because of that salient feature that nickel metal hydride, once it's dead, if it's not damaged, it can actually be revived. It's actually intended. The intention when it was designed is for that. Unlike, okay, now you got to go to John Bedini to try to revive a dead lead acid, for instance. But nickel metal hydride is already prepared and set up to make it possible to do that. So I figured, you know, that's the best choice of batteries to go with. That's why Matsushita was sued by Chevron, because Chevron bought the controlling share for the nickel metal hydride battery technology from, was it Gulf or Shell Oil? I forget. I think it was Shell Oil. Yeah, not Gulf. It was Shell Oil who owned the controlling share when the Iris and, what's the guy's name? Stan and Iris Ovshinsky team of inventors invented the nickel metal hydride battery about 20 years ago. They came out with it. And it was the foundation for the first generation electric car between 1997 or 8, actually, 1998 and 2003. 1997, the EV1 from General Motors had lead-acid batteries, and then they realized, oh, let's use the nickel metal hydride. So, but Stan and Iris made the mistake, and they regretted it afterwards, of selling the controlling share to Shell Oil Company. And then they went and sold their controlling share to Chevron, and Chevron sued Matsushita, and Matsushita was in charge of manufacturing the lead-acid batteries for Toyota, because Toyota was taking the RAV4 and literally converting it over to electric. They didn't even bother to design a whole new car for electric use, because this was just a test production run of 1,400 vehicles. They didn't really... I believe it was 1,400. They didn't really it wasn't intended as a full production run. So they just took out the engine from the RAV4 from that model year and put in 2 AC motors and a double-sized battery pack, which 1,100 pounds, that's a lot. 24 batteries, 12 volts each, 95 amp hours each. That's a lot of battery weight. And so it makes the car something like 3,100 or 3,400 pounds in curb weight. And it gave it a 142-mile range when the batteries were brand new. My batteries are now dead, so I don't know what state they're in, damaged or otherwise. But what the guy on Ritalai website said, when you use high voltage, low amperage, you cannot go back to the other way of charging. It conditions the battery to only accept this new way of charging, and it makes them last longer. So I thought that was interesting. My charger, it's you can make it any way you want, high voltage or low current, or high current, low voltage. You know, that's up to you how you play around with the resistor. But the resistor has to be initially 1.5 ohms when you're surging up to your range of how much energy you want to have. And then you have to go into dissipating mode, in which your rate of surge is less than what you lose to the usual rules and laws of thermodynamics, so that now you can diminish the circuit, the power level of the circuit, and use it up, what you've surged to. But getting it to work in LT Spice was the kicker, because LT Spice is the beginning of pay dirt, you know, making something realistic. I managed to make my simulation of the Joseph Newman motor realistic, not knowing that there was a secret that Joseph Newman was keeping from everyone. And then I didn't know what to make of my discovery, you know. 100,000 cycles per second is the RPM. Whoever heard of such an RPM? Cycles per second, 100,000. Then it's over unity. So when he kind of lied, he kind of didn't lie when he said just make the circuit bigger. It's not the circuit you make bigger, it's the frequency you make bigger. So you see, he wasn't really lying, but that's the way, Tesla did the same thing, did JP Morgan. Oh, I'm not going to broadcast power from Wardenclyffe, just communications. Well, yeah, that's what electricity flowing through a wire is. It's just information. There's no power being transferred through the wire. But of course, Tesla and I think alike, but nobody else does. So JP Morgan got the wrong message. Anyway, I did a whole video about that. But anyway, Tesla didn't lie, I think is the title of it. Or he did lie or something like that. So what's the expression? I forget the idiomatic expression, the test, the acid test. We'll stay with that. The acid test is to break free of the free simulators and go to the Berkeley Spice style of simulators, such as LT Spice, which is free. That's true. But it is based on Berkeley Spice, and Berkeley Spice is considered a standard in the industry of simulators. There are others, anything that costs $5,000 or more is usually considered a standard, but LT Spice at least is given away for free. It has some weird restrictions, like you can't do provocative transformers of multiple coils. All you can have are 2 coils, and then it warns you with an error message. That's not a transformer. What? I can make any one. Well, in microcap, you can make any kind of lumped set of inductors you want to. But microcap also only has a transformer with 2 coils on it. So that, it's kind of weird. But LT Spice doesn't have a transformer. All you can do is take lumped inductors and lump 2 of them, and that's it. So LT Spice has its limitations, but it is based on Berkeley Spice, and that's the important thing. So I wasn't sure how I was going to go about it, but now that I know what I did wrong, and assuming I did it right, I have to ask myself, okay, but I must have done something right, because the Bewley archetype only works in the realistic simulator and in the private edition simulator, both of which had been modified by me, off of Paul Falstad simulator, with the intention of having series resistance in the caps and coils, even though that's not what I ended up doing. So I thought, okay, what did I do, and how do I make LT Spice do it? So that's what my intention was, and it could be that's what I ended up doing effectively. I don't know. That's all I could say. What do I know? Duh. I don't know anything. I just bumble and stumble along. See, I do things backwards. When you go to school, they teach you the theory, and then you do your lab, right? You do your homework, the lab, right? That's the lab, is your homework. Take your homework home and practice all the equations, and you solve all the equations. And, why do we have to keep doing this? To get the routine down in your brain so you can pass the test at the end of the week. Well, I do it the other way around. I bumble and stumble through the lab, not knowing the hell what I'm doing. And then when I think I got something, I thought, okay, now what is that? And then I know what to ask. And I go to the teacher. And who's the teacher? Usually it's Eric Dollard, because he's already covered the ground. Years ago, he's already stated the facts of the matter. But now at least I'm smart enough to ask, what's parametric amplification? Because I kept seeing it for a year, and I thought it was a screwy anomaly of the Paul Falstad simulator, in which it's busy running. It's one of the few simulators, it's ongoing. You can make changes while it's running. And when you do, the energy level changes. It explodes in your face, or it disappears. It usually explodes. All you have to do is change a resistor or something. So it's really uncanny. It's what's going on here? Well, that's parametric excitation. You're changing parameters, and you're synthesizing new electricity that wasn't there before off of the electricity you already have. Or you're making it disappear, but usually it appears rather than disappears when you're making changes to components. You can make it disappear if you make a circuit specifically designed for that, but usually it explodes in your face. And people would come to me and say, look what I did. Oh, yeah, I know, I can do it too. It's just because Paul Falstad makes it so easy. But how do you do that in LT Spice or any Berkeley Spice? It's not that easy. They make it hard for a reason, because it's realistic. Yeah. So now I know how to do it in LT Spice. I haven't tried to see if I can do the same thing in Microcap, but in any case, so I found it to be very interesting and provocative, and I hope I don't have an ant crawling up my sleeve. I have ants in my bed at the moment. Ugh. Maybe I should wash the sheets. Yes, it could be a good idea. Anyway, ooh. So that's what I did today, and I solved the problem, and I thought I'd share it with you because I thought it's so mind-ripping. It's like, wow, blows me away. Don't know what it means? Yeah, so what it means is now that I've done it, maybe eventually I'll find somewhere, maybe Eric talks about this or somebody else, maybe Jim Murray or somebody, what did I just do? What does it signify? Because unless you know what it is, what the simulation is showing you, how are you going to build it if you don't know what if you don't know how to translate and convert the simulation into instruction set of how to build it? You know, I've learned on my own certain little factoids of a simulation to how to translate that into build instructions. But I know I don't know everything. I just know a few things, you know. It's like, because I bumble and stumble and fumble my way through. So now I have here now the experience that now I can go and look for what's the explanation for what I've just experienced. You know, as people will say, oh, you tricked the simulator. You broke the simulator. No, I didn't. It gives you little windows to enter the values, you know. And if it didn't like negative, it would tell me so. It would give me an error message. Trust me, those simulators, they know how to program it. If they don't want you doing something, they let you know right away. Oop, floating node, you got to put a ground here. Shit, I got to put a ground. I don't want to put a ground. But I've learned, see, not to do it the way they say to do it on the internet. You do it, I do it my way. I put a capacitor in between the ground and the circuit. Ooh, I'm so crafty. And that way I get no DC bleed. AC, yeah, but AC goes back and forth, right? So I don't lose anything, right? And that's the whole point. Don't lose anything. It's grounded. So I put a 10 pico farad capacitor in between ground and the circuit at a floating node point in which the circuit tells the simulator tells me, floating node here, you got to correct this. No problem. And it actually enhances the action of the circuit, because most of my circuits are all oscillatory circuits. They're not DC circuits. I wouldn't know how to create an over unity DC circuit, quite frankly. I've never done it before. They're always oscillating circuits, and they always have their own frequency, and it varies whatever it happens to be. Lock stock with 60 cycles. Are you kidding? That's the easiest way to kill over unity like that, and never allow it to happen. No. You want oscillations to roam free, whatever it wants to do. You can adjust it by changing the size of your caps and coils, but it has to march to its own drum beat. You can't, because if you lock it to 60 cycles, then you've locked it to your voltage source, and the analogous term for voltage source is what I call an anchor weight, but the parlance is a voltage regulator, because that's what a voltage source does. It regulates the voltage. It doesn't just feed you voltage, it regulates you while it feeds you. So I like to use a snap switch and just put in the voltage and then turn it off right away. It's on its own from that point on. It's better than worse treatment than I got. I got babied in my childhood. But no, this one's just for an instant, and then the circuit's on its own. It's got to increase its energy or diminish it according to what you want it to do, but it's no longer tied to a source anymore. Yeah, it's an uncanny idea, you know? Where's your source? Where's your energy coming from? So what somebody asked on Quora today, you know, I'm trying to tell them, well, it doesn't come from anywhere. It's true, energy moves around in the universe. Not quite true, but I had to concede something for his sake. But it ultimately doesn't come from anywhere. It comes from the manipulation of time. That's where energy comes from. And, that'll be a hard concept for people to understand, They got to, what's that? Fancy sidestep dancing you're doing here? Well, it's not so fancy. It's called electrical engineering. And I'm teaching you, and I'm not even an electrical engineer. Shit. We are hopeless, I'm telling you. We are quite hopeless. Okay, so I'm going to shut up now.